Is hydrogen really the climate savior we've been hoping for? A groundbreaking new study throws a wrench in the works, suggesting that hydrogen might actually be contributing to global warming, even if in a small way. This is huge, because hydrogen has been championed as a clean alternative to fossil fuels, especially for industries that are hard to decarbonize. For years, the promise of hydrogen has revolved around its clean use: burn it, and all you get is water vapor. Advocates envision a future powered by hydrogen in transportation and heavy industry, a future free from the polluting effects of fossil fuels. But here's where it gets controversial. The research, published in the prestigious journal Nature, https://doi.org/1038//S for 1586-025-09806-1, reveals that hydrogen plays a subtle yet significant role in trapping methane, a greenhouse gas far more potent than carbon dioxide. While hydrogen itself isn't a direct pollutant, its presence in the atmosphere extends the lifespan of methane, exacerbating the greenhouse effect. Think of it like this: hydrogen is inadvertently helping a climate villain stick around longer. Related, polar bears may be evolving to survive in a warmer world. https://www.sciencealert.com/polar-bears-may-be-evolving-to-survive-in-a-warmer-world. The study meticulously tracked hydrogen emissions from 1990 to 2020. The findings? These emissions contributed a small but measurable 0.02 degrees Celsius to the nearly 1.5 degrees Celsius increase in average global temperatures since the pre-industrial era. That might seem insignificant, but every fraction of a degree counts when we're trying to avoid catastrophic climate change. And this is the part most people miss. It's not just about the direct warming effect, it's about the complex interactions in the atmosphere. As Rob Jackson, a Stanford University scientist and senior author of the paper, aptly puts it, we need a deeper understanding of the global hydrogen cycle and its links to global warming to support a climate-safe and sustainable hydrogen economy. https://sustainability.stanford.edu/news/overlook-hydrogen-emissions-and-supercharging-methane. The study underscores the need for a more nuanced perspective on hydrogen's role in our energy future. The research, conducted by the Global Carbon Project, an international team of scientists, attributes the rise in hydrogen emissions primarily to human activities. Specifically, they link the increase to methane emissions from fossil fuels, livestock, and landfills. But how are methane and hydrogen connected? The connection lies in the breakdown of methane in the atmosphere. When methane decomposes, it produces hydrogen. So, increased methane emissions, regardless of the source, inevitably lead to higher levels of hydrogen in the atmosphere. The primary concern isn't hydrogen's direct impact, but rather its indirect effect on methane. Hydrogen absorbs atmospheric detergents, molecules that naturally break down methane. By reducing the concentration of these detergents, hydrogen effectively prolongs methane's lifespan. Zutao Ouyang, the study's lead author and an assistant professor of ecosystem modeling at Auburn University, explains this process clearly. More hydrogen means fewer detergents in the atmosphere, causing methane to persist longer and, therefore, warm the climate longer. https://sustainability.stanford.edu/news/overlook-hydrogen-emissions-and-supercharging-methane. Furthermore, hydrogen's interactions with atmospheric detergents can also impact cloud formation and contribute to the production of other greenhouse gases, like ozone. https://www.sciencealert.com/ozone, and stratospheric water vapor. It's a complex web of interconnected atmospheric processes. Beyond methane breakdown, the study identifies leaks from industrial hydrogen production as another source of atmospheric hydrogen since 1990. Currently, hydrogen is manufactured through various methods, including electrolysis, where an electric current splits water into hydrogen and oxygen. Related, first signal of climate change became detectable 130 years ago, https://www.sciencealert.com/first-signal-of-climate-change-became-detectable-130-years-ago. However, most hydrogen production today relies on natural gas or coal, energy-intensive processes that release significant amounts of carbon dioxide. This underscores the importance of transitioning to green hydrogen production, which uses renewable energy sources. While the goal is to scale up green hydrogen production, the high costs and technological hurdles remain significant challenges. This study raises important questions about our reliance on hydrogen as a climate solution. While it still holds immense promise, we need to be aware of its potential downsides and invest in research to mitigate these risks. Could focusing solely on hydrogen be a mistake? Should we be prioritizing other renewable energy sources and carbon capture technologies? What are your thoughts on this? Share your opinions in the comments below.